Hey folks, this is our first set of video notes for stoichiometry. We're going to do the very simple mol-to-mol stuff to start out with. Stoichiometry is a series of mathematical conversions, like those unit conversions we did before, but we relate them to our balanced chemical equations, and it helps us to figure out how many or how much of the reactants of each ingredient we need for our recipe, and how much of the products we're going to make. So essentially, we do a little bit of this super easy math, this conversion math, to figure out how much we're going to make or how much we need for our recipes or our equations. Basically, it's the same as baking with a recipe. If you want more out, you got to put more in, but you have to do those calculations to make sure you have exactly the right amount with nothing left over. So it's just a series of conversion factors or proportions that we pull straight from our equations. And again, those equations have to be balanced. Remember that a coefficient in front of a molecular formula in a chemical equation, that tells us how many particles or molecules we have in our recipe. But we also have this number called a mole. Each mole has 6.022 times 10 to the 23 particles. So instead of just saying, oh, I'm going to take one molecule of hydrogen and one molecule of oxygen and make something, we could talk about it in larger groups. Using the same numbers, 2 and 1, or whatever those coefficients happen to be, we could just be talking about this large number of particles, because that makes a little bit more sense when you think about maybe you're putting a spoonful of particles in there or something. But anyway, if we have a 2 in front of the H2O, we could describe it as having 2 moles, or as 12.044 times 10 to the 23 particles. For the first set of our stoichiometry learning, we're going to stick with this mol-to-mol conversion. We'll use this equation because it's one that we're pretty familiar with from the other notes. But according to this, with these coefficients here, basically for every 2 moles of hydrogen gas we have, we react 1 mole, remember the 1 is invisible, of O2, and we produce 2 moles of H2O. So when we're given a problem that says how many moles of water would be produced from a reaction that completely uses 10 moles of H2, we'd solve it like we would a normal unit conversion problem. The first step is to write down what we know, which is saying that we know we have 10 moles of H2 that gets used. And then we look to our chemical equation to say, all right, how can I cancel out a unit? Well, I could put moles of H2 on the bottom down here, and according to our equation, 1 round of this reaction takes 2 moles of H2. But we want to get to moles of water, so how many moles of water are produced in this reaction each time it goes through? Well, again, according to our equation, it says there's 2 moles of water. So then what that essentially does is cancel out our moles of H2 and converts it to moles of H2O. And when we do that math, 10 times 2 divided by 2 gives us 10 moles of H2O. Using the same equation, maybe we start with 10 moles of O2. How much water are we going to get out? Same thing, write down what we know, 10 moles of O2. We want to cancel out that unit. According to our equation, we use up, each time we go through the reaction, 1 mole of O2, and we still produce 2 moles of H2O. So this time, our moles of O2 cancels out, leaving us with moles of H2O, and we get a total of 20 moles of H2O produced. Let's try it with a different equation here. How many moles of CH4 do I need to fully react in order to produce 30 moles of H2O? So this is kind of the same thing, but in the backwards order. So what we know we have is 30 moles of H2O. According to reaction, each time this reaction goes through, we create 2 moles of H2O. So we write that down here. And in order to do that, it takes 1 mole of CH4. And that's our conversion. It crosses out moles of H2O, leaves us with moles of CH4. 30 divided by 2, or times 1/2, gives us 15 moles of CH4. This time, how many moles of O2 do I need to fully react in order to produce 30 moles of H2O? Same thing, write down what you know, 30 moles of H2O. What does the equation say? We make 2 moles of H2O. That's going to go on bottom because we want to cancel out. Every time we make 2 moles of H2O, we have to use 2 moles of O2. And there's a conversion. 30 times 2 divided by 2 gives us 30 moles of water out, or 30 moles of O2 that we need in order for that reaction to go through. Again, this is the very basic form of stoichiometry that we'll do. So if you have questions about this, please ask them before we start moving on to the moles to grams ratios, because that stuff gets a little bit trickier and you need to get this first.